Here we will study about the smart city IoT architecture, how the layers of the architecture are divided, what will be the different applications provided, what different services are provided, and what activities are done. We will see. So this is the smart city architecture, which consists of 4 layers. The bottommost layer is the street layer, above that is a city layer, above which is a data center layer, and the final one is the services layer. Okay, so here in the street layer, it's the bottommost layer, we can say it is the edge layer, where all the devices and the sensors will be placed for generating or gathering the data from different utilities. Maybe it is a parking, waste management, hospitals, schools, shopping, etc. So for all those different utilities available in a smart city, the sensors are deployed in different places and the data will be collected from those sensors, and little pre-processing happens in the edge layer. Then the data will be transferred to the city layer. So we can say the city layer is a fog layer. So the city layer has some routers and switches which will collect the information from the street layer and perform again little pre-processing and aggregates it, and through some protocols it will transfer the data to the data center layer. It will collect the data from the street layer, then transfer it to the data center layer. So data center layer is nothing but the cloud layer, where the data aggregation happens and data analytics will happen, and the data will be analyzed and some insight out of that data will be found out. After that, above that data center layer, we have services layer. So this is a 4-layered architecture. So in the services layer, the topmost layer, we have different services provided for different utilities of the smart city, like we have parking management, lighting management, safety and security, and traffic management. So all these services will be provided by the smart city, and those will be provided through applications and dashboards. That means you will be having some apps for which you will be able to utilize these services. For example, if you have a parking app, then in a particular area when you travel, you can just open that app and find out where the free parking space is available, rather than moving around in the streets to find out the free parking space. You can just find out through the app, and directly you can go there and place your vehicle. So that will be a wonderful thing, right? So such services are provided in the services layer through some applications. So this is the smart city architecture. So when this question comes, you can just write this this portion of the 4-layered architecture. So the first comes the street layer, where the sensors and devices are deployed, which generates the data. Then city layer will collects, and it has some routers and switches which will do some pre-processing and forwards it to the data center layer. Here it will be aggregated and analyzed. Then in the services layer, it will be giving you services through the applications. So that is the overall summary of the smart city IoT architecture. So then here in this part, Cisco have given some of their products which will provide smart city operations. Then the services for smart city by Cisco and their partners in smart city project. Then these are the delivery models: on-site cloud, partner cloud, and private clouds. They are using for storage and analytics. Then the outcomes of the smart city. These are the outcomes of the smart city IoT architecture. What is the outcome is new governance model implementation in cities. So governance will be there. Then unifying foundation platform with ROI, that is region of interest, in 10 years depending on use case deployment like traffic, parking, lighting. So in another 10 years region of interest will be found out, and they will be set as data collection areas. Then IoE. So what is IoE? IoT is Internet of Things. IoE is Internet of Everything. So everything will be connected to internet in another 10 years, they say. So IoE enabler for third party sensor implementation. So any third party, if they want to implement sensors for their utilities, that will be enabled. Then new smart services for cities and citizens will be available. So this is all the overall summary of the smart city IoT architecture. So let us see some more details on this. A smart city is a four-layered architecture. Data flows from street layer to city layer, and it connects city layer connects the data city layer connects to data center layer, where data is aggregated, normalized means simplified, and virtualized. Then data center layer provides information to the services layer, which is a topmost layer, which consists of the applications that provide services to the city. So services layer has applications to provide services to the city. Coming to the street layer, the street layer is composed of devices and sensors. We have studied that, right? It consists of devices and sensors which will collect the data and take some action. Then ICT is information and communication technology. ICT connectivity solutions collect data from sensors, analyze and use it to operationalize use cases for cities. So this information and communication technology will collect the data from sensors, and they will analyze it and use it for the use cases of the cities. A variety of sensors on the street layer will be deployed for different use cases of the smart city. So the sensors are like this. The magnetic sensor will sense the heavy metal objects, for example a car or a truck. So we can say the movement detection. It will detect the magnetic sensor will detect a parking event by analyzing changes in the surrounding magnetic field. Okay, whenever a heavy metal object arises, this magnetic sensor will sense it. Then lighting controller. See, all these we have seen in Raspberry Pi programming, right? Movement detection, light detection, and all those things. A lighting controller can dim and brighten a light based on a combination of time-based and ambient-based conditions. So, if more light is detected, more light is needed, it will increase the intensity of the light. If you are watching TV, then intensity required is less, so it will reduce the intensity of the light. So based on the activity what you are performing, the light will be, intensity of the light will be increased or decreased. Then video cameras. So video cameras with video analytics can detect vehicles, faces and traffic conditions for traffic and security use cases. Cameras with video analytics, they will be having capacity for analytics also. They can detect the vehicles, they can detect the faces and also traffic conditions, heavy movement of vehicles is there or less is there, so that it will identify, and it can be used for security use cases. If any theft or any crime happens, then also video cameras can detect and notify. Then air quality sensor, it will detect and measure the gas and particulate matter concentrations to detect pollution in a given year. So air quality sensor will be providing us to find out the pollution in the air. Then and what measures we can take, we can do it, purifying or reducing the traffic or whatever we can do. Then device counters, it will count the number of devices in a particular area, which can be used for some calculations or some analytics. Next, the city layer. City layer, network routers and switches must be deployed to match the size of the city data that needs to be transported, isn't it? We have seen in the city layer there are routers and switches which will be deployed. To how many routers and how many switches will be decided based on the size of the city. So this city layer aggregates all data collected by sensors in the street layer and the end node network into a single transport network. So it will collect the data from the street layer and pass it on to the data center, that is the cloud layer. The city layer may appear to be transport layer, isn't it? So it collects the data from edge layer and transport it to the cloud layer. So it can be a transport layer between the edge and the data center or the internet. A key consideration of city layer is that it needs transport multiple types of protocols for multiple types of IoT applications, because in the edge layer different types of data, different formats from different platforms will be arriving. So city layer need to convert it into a common format and to a common platform, and then it need to send to the cloud layer. So here it needs multiple protocols for multiple types of IoT applications. Some applications are delay and jitter sensitive, and some other applications require a deterministic approach to frame delivery. That means in some applications the response time will be very much high, like in parking, okay, in traffic management it should be informed at the earliest, right? So data sent to the cloud, analyzed, and it has to be responded immediately so that the traffic management happens in an efficient way. Either if a particular route is crowded, then the person can take an alternate route. So if it is not intimated well in advance, then it will be of not much use. So they are jitter sensitive. So such applications should be taken care of in time. City layer must be built to ensure that packet coming from a sensor or a gateway will always be forwarded successfully to the head end station, that is to the cloud. So whatever it receives from the street layer, it should ensure that all of them successfully transfer to the cloud layer. So this is the connection between the street layer and the city layer. So here the street layer will collect information from different access points, then it will transfer it to the city layer. City layer has routers and switches which will collect, aggregate the data, and again it will route them to the cloud layer above the city layer. Then the data center layer, which is nothing but the cloud layer. So data collected from sensors is sent to the data center where it can be processed and correlated. Do you remember correlate function which we had studied in the streaming analytics? Correlate means it will whatever the current data, real-time data it has received, that will be matched with the stored data history, and it will derive something. So if pattern is changing, then it will derive some insight from it, and it will take the corrective measures. Based on this processing of data, meaningful information and trends can be derived and automated response can be generated. So based on this data, means after analyzing that data, some basic meaningful insight will be taken, and response to the edge will be generated. For example, traffic information can be processed to automatically regulate and coordinate the street light durations at the scale of entire city to limit traffic congestion. So traffic lights street lights can be regulated based on the traffic. If the traffic is more, then continuous street lights will be provided. If the traffic light is very scarce, like one or two vehicles in 10 minutes if it is coming, so continuous street lights providing will be wastage of energy, right? So whenever the vehicle arises, at that time before 1 or 2 minutes the street lights may be on. As and when the vehicle passes through that light, the lights will be switched off, so energy efficiently can be utilized. Data is stored in rented logical containers accessed through the internet, right? So whoever is storing the data, the city management will not have their own containers in the cloud for storing data, right? So it will be rented. Data cloud will be rented, and it will be accessed through the internet. Containers can be extended or reduced based on the needs. So how many containers of data on the cloud is required, that is decided based on the requirement. If the data need to be stored is increasing gradually, then the containers may be as and when requirement comes increased. Or if it is the data is reduced, like in the case of corona lockdown, the data generated will be less, right? Because no people were there on the streets. So then number of containers rented can be reduced. Storage size and computing power are flexible and can adapt to changing requirements or budget conditions. The size of the storing containers can be flexible, so like we can increase or decrease based on our requirement and also our budget conditions, economic conditions. The cloud provides a scalable, secure and reliable data processing engine that can handle the immense amount of data passing through it, right? So it provides a scalable, means you can increase or decrease the size, and it is secure and reliable data processing it will provide to analyze the data. Humidity level data, so for example here, humidity level data can be used to regulate the color and luminosity of street lights, right? So humidity means like if the street lights are required, intensity of street light is required more, like in summers the days will be longer, right? So even after 6:30 also there will be light outside, so then we don't require light. Maybe at 7 o'clock it becomes darker and then street lights may be on. But in winter days will be shorter. By 6 o'clock itself the day will be dark, right? So at that time 6 o'clock only the street lights can be switched on. So based on the humidity level you can regulate the luminosity of street lights. So this is the role of cloud for smart city applications. So here all these are the edge layer where the devices and sensors are deployed and the real-time data is generated, which will be collected by the different fog nodes, and then it is transferred to the cloud for storage and analysis. So here different nodes are like, it is having municipal command and control center, smart grid, hospital, network optimization, home energy, traffic, factory. So like here, so why we call this as fog is, on the edge there may be multiple hospitals in a city, right? There are multiple homes, there are multiple streets of traffic, there are multiple factories situated on the edge. So the data of all the factories collected by the fog, data of all the traffic, all streets traffic is collected by the traffic flow optimization. Then the data of all homes are collected by home energy management. and the data of all hospitals will be collected here. So then it will be brought into a particular format using some protocols. It will send it to the cloud, and here all these data of a particular city, the hospital data, the home data, traffic data, factory data, etc., will be analyzed here and correlated, and then some insight will be brought out so that all of them can be efficiently managed. Next, the final layer, the topmost layer, which is the services layer. The data collected should be visualized according to the specific needs. So now data center layer, which is the cloud layer, will store the data and analyze it, but after that it should be visualized in a proper way and it should be used, right, for which is beneficial for each consumer of the data. So that will be given by the services layer. For example, the parking data indicating free spots for a citizen is given by the services layer, and for officer utilization and payment for the public parking space. See, one type of data can be used by different end users. So parking data is used by the citizen to find the free parking lot, and similarly by the officer to accept the payment from the public. So same data can be used, same parking data can be used by different end users. Traffic information help individual car drivers to find least congested route. So then alternate routes can be taken. Then public transportation users to estimate travel times, like if you are traveling in a bus or a train, then you can estimate based on the traffic information. So at what time you will reach your destination, so that estimation you can do. Then number of subway trains can be increased. If the more traffic is there, more number of people are traveling, then subway trains numbers can be increased dynamically to avoid the congestion. Smart city can incorporate any number of applications that consume data from the cloud. Then the smart city security architecture. So not only using the smart city for our benefit, but it also should be secured, right? So how much amount of data is generated and is traveling. It is a data under motion. It is traveling from edge to cloud, edge to fog and fog to cloud. So it is under motion. So it need to be secured. A serious concern of most smart cities and their citizens is data security. Vast quantities of sensitive information are being shared at all times in layered real-time architecture. So sensitive data is available, right? Your data, your hospital data, your traveling data, your shopping data. So different sensitive information will be captured. Cities have a duty to protect their citizens' data by the unauthorized users and avoid tampering. A security architecture for smart cities must utilize security protocols to fortify for each layer. So security protocols must be used by the architecture to provide security for the data of the city. For example, hijacking traffic sensors to send false traffic data to the system regulating the street lights may result in dramatic congestion, right? So street lights or traffic lights hijacked, if it is not properly secured, and it is misguiding the people who are traveling in the city, it will create different congestion issues. So the security is of highest priority. The security architecture should be able to involve the latest technology and incorporate regional guidelines. For example, city bylaws, country or regional security regulations. So next is the security, how the security will be provided. The following are the common industry elements for security on the network layer. The security on the network layer through firewall. A firewall is located at the edge and it should be IPsec and VPN ready. So at the edge only the firewall should be located, because the data is gathered on the edge, and it should be IPsec and VPN ready. What is IPsec? IPsec is a secure network protocol suite, provides secure encrypted communication between two computers over an IP network. It is used in VPNs. So VPN is a virtual private network. It gives you online privacy by creating a private network from a public internet connection. So then a VLAN provides end-to-end segmentation of data transmission, further protecting data from rogue intervention. So it will provide the segmentation of data for transmission and avoids the intervention. Actually, VLAN is a virtual LAN, it stands for, is a customer network created from one or more existing LANs. It enables groups of devices from multiple networks, either it is wired or wireless, to be combined into a single logical network administered like a physical local area network. Then encryption. Encryption is converting the original data to some other form so that it is not attacked and understood by an unauthorized user. Protecting the traffic from sensor to the application is a common requirement to avoid data tampering and eavesdropping. In most cases, encryption starts at the sensor level. So at the sensor level in the edge, encryption starts. In some cases, sensor to gateway link uses one type of encryption. Sensor to gateway in the sense, edge to fog one type of encryption, and gateway to application, that is fog to cloud, another type of encryption will be used. So it will be difficult for an intruder to track the data and understand the data. So encryption will provide the security. Firewalls at the edge, VLAN for avoiding intervention of the intruder. Then encryption for conversion of data, different levels of conversion, one level from edge to fog and another level from fog to cloud. So all these security measures will be taken in the city architecture to provide utmost security to the sensitive data of the citizen, which is in motion. Okay, by this discussion we are completing the Internet of Things subject. All 5 modules are completed with this discussion. So if you have any doubts, you can contact me through phone or WhatsApp. I will be available, and all the best for your exams. Do well. Thank you. Have a good day.